two subgroups, and half of the points will be in the group number 1 and half of the points will be in the group number 2. Now here, if I divide this given set of points into the two groups, so one of the groups may rise from say x1 to x1, y1, x2, y2, and goes up to say xk and yk. So this is the points we are going to take in the group number 1. And similarly, the remaining points will be in the group number 2, and those will start from xk plus 1, yk plus 1, similarly xk plus 2, yk plus 2, and if we keep on writing, the last will be of course x and y. So these are the two groups of the given set of points. Now here let me tell you the basic idea of basic principle of making the two groups we generally use in order to solve the various problems. Whenever you have even number of points, suppose you have 6 points, you have 10 points, you have 12 points. So in such a way, whenever the situation appears like that, so we take half of the points in one group and half of the points in the other group. Means if we have 10 points, so 5 will be in the first group and 5 will be in the second group. Similarly, if you have 6 points, then you will be having 3 in the first and 3 will in the second. So this is the general principle we use to group the data. But whenever you have odd number of set of points, so generally we use the principle having one more point in the first group and of course one less point in the second group. For example, if we have 7 points, so 4 will be in the first group and 3 will be in the second group. This is the general principle we use to group our data points. Now we have made 2 groups. One of them is from x1 to xk, and the other one is xk plus 1 to xn. Now, after doing this, if I use the set number 1, then according to the principle we have decided for the whole procedure, for the whole method, so here the elements of the group number 1 will be giving you the index I goes from 1 to k, and the sum of all the differences for this particular case, if I represent it by the straight line, because we are using the straight line to pass, so here this will be yi minus a plus b times xi, and I goes from 1 to k. So this will be the sum of all the differences for the set number 1, and this sum is equals to, according to the theory we have developed, should be equals to 0. Similarly, for the second group, the result will be I is equals to k plus 1 and goes to n di, and sigma I equals to k plus 1 to n and then yi minus a plus bxi, and the sum in this case will be also equals to 0. So these are the 2 questions basically we are going to develop by using the same principle we have developed in the start. The sum of all di's should be equals to 0. So these 2 questions are based upon this principle. After constructing these 2 questions, now we are using a bit algebra and the basic properties of the sigma notation you already know. So here we are going to apply them. So let me erase it from here just for you to create a space here to write. Okay, after doing this, now we are using the equation number 1. This is your suppose question number 1, I'm using it here, and this sigma notation can now be distributed within the bracket. And if I drop this and use only this side and make it equals to 0, then I get the result of sigma I is equals to 1 to k yi minus I is equals to 1 to k a plus b times xi, and the sum is equals to 0. I'm not using this part, I'm taking this side only and making it equals to 0. Similarly, from the second equation we can write down the result is equals to sigma I is equals to k plus 1 to n yi, and minus sigma I is equals to k plus 1 to n a plus bxi. Okay, so here you can see we got these two results from these two questions. Now, after constructing these, the next is if I transform, shift it, if these two parts, I'm going to shift them to the right side and keeping these two parts on the left side. So here we get the next result of the form sigma I is equals to 1 to k yi is equals to sigma I is equals to 1 to k a plus b times xi. Sign will change whenever we shift it to the right. Similarly, from the second we get sigma equals to 1 k plus 1 to n, and then yi is equals to sigma I equals to k plus 1 to n, and inside this will be the same result. So far here we have used simple algebra, and the next we shall be using the properties of the sigma operator. Okay, after doing this, the next step is to bring this sigma inside the bracket. So from the first equation we get sigma equals to 1 to k yi is equals to, now you can see here this sigma will be distributed to both the quantities inside. So sigma equals to 1 to k a plus b plus sigma I equals to 1 to k bxi, and from the second equation we get sigma I equals to k plus 1 to n yi is equals to sigma I is equals to k plus 1 to n a plus sigma I equals to k plus 1 to n, and then bxi. Okay, this is very straightforward distribution of sigma notation inside the bracket. Now we know that whenever we apply the sigma, the constant doesn't change, and we can bring them before the sigma notation, and remaining sigma will be applied to the remaining part of the whatever the function is there. So let me write few more lines or few more steps. Okay, after doing this, now I'm taking this a outside the sigma notation, and sigma I equals to 1 to k will be now applicable to 1 only, and we all know that whenever we apply to 1, then this result will be equals to k times sigma a. So here we get the result sigma I is equals to 1 to k yi, and the result takes form k times a from here, and from here b can be taken out. Inside this gives you sigma equals to 1 to k and xi. Now from the second equation we get sigma I is equals to k plus 1 to n yi, and similarly as we have done this here, taking a outside and remaining sigma will be applicable to 1 only here. So there are n minus k terms, so this gives you a into n minus k, plus from here b can be taken out. Inside this will be sigma equals to k plus 1 to n and xi. So these are very straightforward steps, and you can verify these results directly from your intermediate books. These are available there. Okay, after doing this, the next step is I'm going to divide this first equation by k and the second equation by n minus k throughout. So whenever I do this,